So in this lecture, we are moving on to Mohr's circle, which is the graphical method to find the solution for different types of stresses on an inclined plane. Okay, we have already seen the analytical method to solve the different types of stresses and forces on an inclined plane. Now we are moving on to the graphical method. It is known as Mohr's circle. Now, what is this Mohr's circle? It is, as I have already said, it is a graphical method for the stresses on an oblique section of a body. Otherwise, it is known as Mohr's circle, and the determination of normal, shear, and resultant stresses across a section is done graphically by drawing a Mohr's circle of stresses, and it is very easy method. Less errors will be there. So these are the advantages of Mohr's circle. Now we'll see how to draw a Mohr's circle and how to find the normal, principal, and shear stresses by using a Mohr's circle. So before that, before moving on to the uh, procedure for drawing a Mohr's circle, we'll see what is the sign conventions used. So as in the figure you can see all the angles traced in the anti-clockwise direction to x-axis. That is, you can see if you're drawing anti-clockwise to x-axis, then we can take it as negative, and if it is clockwise to x-axis, then we can take it as positive. And the measurements above x-axis is taken as positive, below x-axis is taken as negative, and the measurements right side to y-axis is taken as positive and left to y-axis is taken as negative. So this is the sign convention mainly used, and it is very common convention, sign convention. So this can be followed for drawing a Mohr's circle. Now we have seen actually three different types, three different conditions to find the stresses on an oblique section. So here in this particular example, you can see a oblique section. Okay, this is an oblique section having a principal stress, only one principal stress in one perpendicular direction, that is sigma. So you can see sigma here. Sigma n is the normal stress, as I have explained in the theoretical class. Now tau is the shear stress. When we are cutting an oblique section, there will always be a shear stress. So tau is the shear stress, sigma n is the normal stress, and sigma is the principal stress which is acting on the body. So this is the first condition which we have discussed in the previous class. Two more conditions are there in which the sigma or the principal stress acting in two different directions, sigma x and sigma y will be there, and in another condition shear stress will be acting in both the directions. So there are three conditions, but in this particular session, to know what is Mohr's circle and how to draw a Mohr's circle, what is the procedure for drawing a Mohr's circle, how to find the normal stress, shear stress, and the resultant stresses using a Mohr's circle, I will explain that particular things based on only one example. The other two examples you have to draw by yourself. So I'll explain the first example. This is the first example in which an oblique section is there. A, C, B is the oblique section having theta as the angle of obliquity. That is the angle of what is that? Angle of the triangle forming the section is theta. Now there is one sigma is there, sigma which is acting at xx direction, that is on the face AC, and sigma n is the normal stress which is acting on the direction AB, so on the face AB, and tau is the shear stress which is acting in the face AB. So this is about the things which have to be explained about the drawing. So we are going to draw the Mohr's circle for stresses in an oblique section of a body subjected to a direct stress in one plane only, that is sigma. Okay, you'll see. So first of all, what we have to do is, so this is the procedure for drawing a Mohr's circle in this case. The first step is you have to take some suitable point O. We are taking some suitable point O and we are drawing a straight line. We can name it as XX. So when we are connecting O to XX, we will get XOX. This is a straight line. We are randomly drawing a straight line. Now we have taken a point O here. Okay. In the second step, what we are doing is, in your question, there will be given how much is the stress which we are applying. Okay, that tensile stress we are applying will be given in your question. For example, 10 Newton. So 20 kilonewton or 50 kilonewton or 100 Newton, whatever it is, it will be given in the question. So you know the amount of stress. That tensile stress which we are applying on one of the plane will be known to you. So you can take that stress to a scale. For example, if you are taking 100 kilonewton, if you are in the question, it is given that a tensile stress of 100 kilonewton is applied on the face of an oblique section, then we can take the 100 kilonewton into scale. That means for 100 kilonewton we can draw a 10 centimeter. 1 is to 10 scale. If you are taking for 100 kilonewton, you can take it as 10 centimeter. Now we are taking it as OJ, that is cut off OJ equal to the tensile stress sigma to some suitable scale and towards the right, because the stress we are in our question, it is given that it is tensile stress, so it is positive, so you have to take it in the positive x direction. So OJ is equal to the tensile stress, the value of the tensile stress. Now what we have to do, this is OJ is the tensile stress. Now the O part will give you the stress system on plane BC. So here you can see this is plane BC. This is plane BC, the base of the triangle. So all the stresses which is applied on the base of the, which will be acted on the base of this triangle, that is on the face BC, will be represented by the O, by the letter O. Now the point J will represent the stress system on plane AC. So this is AC. The altitude of this triangle is AC. All the stresses which is applied on AC or which will be affected on AC will be represented by the point J. Okay, that is a simple thing which you have to note before drawing a Mohr's circle. Now you got OJ, right? OJ we have drawn with by taking sigma into scale. Now what you have to do is you have to take the midpoint of OJ. So here C is the midpoint of OJ. Okay, OJ is nothing but it is equal to sigma. Sigma taken into scale, and we are taking the midpoint. Now what we are doing is we are drawing a circle with CJ or OC. Both are equal. So CJ as the radius, we are drawing a circle. So this is the radius of the circle, we are drawing a circle. So it will intersect the points O and J. Got it? This circle is known as Mohr's circle for stresses. So this is known as Mohr's circle. When you are taking sigma as the diameter of a circle, we can say it as a Mohr's circle for stresses, and we are using this particular circle for determining the normal stress, resultant stress, shear stress, etc. Got it? Okay. Now what is the next step? After that, what we are doing is, in the question you will be given with another value, that is theta. How much is the theta? It will be given to you. So you have to take 2 theta, 2 into theta. For example, if theta is given as 30 degree, then you have to take 2 into theta, that is 60 degree. And you have to draw a line CP with 2 theta as the angle. Okay, a line from the center of the circle, you have to draw a line CP at an angle 2 theta. Got it? In the positive direction, that is in the clockwise direction, because we have to take it as positive, that's why we are taking it as clockwise direction. So the P represents the stress system in section AB. So here in this figure, AB is nothing but the hypotenuse of the triangle. So whatever is the stresses applied on this particular face AB will be represented by this particular point P. Got it? Okay. Now we'll draw this, and now the next step, the fifth step is, we will draw a perpendicular from P to the horizontal line. A perpendicular is drawn from P to the horizontal line XX. That point is named as Q. So PQ is drawn perpendicular to XX. Now what we are doing? Now we are connecting this P to the extreme end. That is, O is the extreme end of this particular thing. Now we are connecting P to O. This angle will be theta. That angle will always be theta. If you are drawing it like this angle will be theta. Got it? So this theta is nothing but it is the angle of obliquity. Got it? Okay. Now it is very easy to find our aim. What is our aim? Our aim is to find the different types of stresses. The normal stress, what is the value of the normal stress? We don't know it. What is the value of the shear stress? We don't know the value of shear stress. What is the value of the resultant stress? We don't know it. So all these things we have to find. It is very easy to find from this particular figure. Here, if we are measuring OQ, OQ is nothing but the normal stress. If you are measuring this OQ, for example, if OQ is 5 centimeter, then if you are taking the entire thing, this OJ we have drawn into scale, right? 1 is to 10 is the scale ratio. Then we can take OQ as 5 into 10, that is 50 Newton. Like that, by converting to the scale, the value of this particular lines, the length of this particular line converting to the scale will give you the stresses of corresponding stresses. For example, OJ is nothing but it is a normal stress, QP is nothing but it is a shear stress, OP is nothing but the resultant stress. So you got the values which we have calculated by means of analytical method in a very simple manner by using Mohr's circle. So this is the thing. This is how you have to find the different stresses. It is a very easy method. So this is for a single force. For two forces you have to look into. The procedures will be given in the upcoming slides, but you have to look for that. Now, how to prove this? You have to prove. We have already told you after drawing this, OQ is normal stress, QP is shear stress, OP is resultant stress. But how to prove that? Is that correct? So that will be given in this particular slide. The proof. Now you listen. So this is our final figure. We have drawn first OJ, which is equal to sigma. Now we have taken the center point. Now we have drawn a circle that is known as Mohr's circle. Now we have taken 2 theta angle and drawn CP. P is the point which is intersecting the circle. Now we have drawn a perpendicular to XX line, that is PQ. Now this angle formed will be theta. So we have to know the proof, right? So after explaining this figure, you have to look into this geometry, the geometry of the Mohr's circle of stresses. Here OC is nothing but it is equal to CJ. OC is equal to CJ. What is OC and CJ? It is half of sigma, right? So OC is equal to CJ is equal to CP. CP is also the radius of the circle. OC is also the radius of the circle. CJ is also the radius of the circle. So all of these are equal, which is equal to sigma by 2, which is the radius of the circle. Now the normal stress sigma n is equal to OQ. We have in this slide we have written it as OQ. OQ is the normal stress. So what is this OQ? OQ is nothing but it is equal to OC minus CQ, right? OC minus CQ will give you OQ. Got it? What is OC? OC is nothing but sigma by 2. Now what is QC? QC is nothing but if this is the 2 theta angle, then QC is equal to CQ cos theta. Okay, you'll get it as sigma by 2 cos theta. So if you are taking the hypotenuse theorem, you will get CQ as sigma by 2 cos 2 theta. Sigma by 2 cos 2 theta. So that value you have. So you can see in your analytical method what we have found, the normal stresses for a single if a single stresses or principal stress is acting on an oblique object, then the normal stress formed will be, the value of the normal stress will be sigma by 2 minus sigma by 2 cos 2 theta. This is the equation you have derived in your analytical method. Hence it is proved that OQ is equal to normal stresses. That's it. Now what is shear stress? The equation for shear stress was sigma by 2 sine 2 theta. In your analytical method you can check that. In the previous slide you can check that. What is the value of 2? Here we have given that QP is equal to shear stress. So what is QP? QP is this one. So what is this QP? If you are taking 2 theta angle and considering this triangle CPQ, QP is nothing but it is CP sine 2 theta, that is sigma by 2 sine 2 theta. So again it has been proved that tau is equal to sigma by 2 sine 2 theta and tau is equal to QP. So again this point is also proved. Now OP is equal to resultant stress. OP, the value of what is the value of OP, you have to calculate and check whether it is equal. So this is about the proof of a Mohr's circle. So with the help of this particular example, you have to solve the other two methods. The second one is if two stresses are acting, sigma x and sigma y is acting, how can we draw the Mohr's circle and how can we prove that the different quantities, that is normal stress, shear stress and resultant stresses will be represented by these lines. How can you prove that? That you have to check. So all the things are given, you have to check it. Thank you.